So today we speak about software interoperability in the field of 3D, how we can build efficient XR workflows. And also I call that pitch 3D software interoperability revisited, because this is perhaps another way we present something, some way to create 3D digital workflow in another way. So we'll visit that. So to begin, I have a simple question. Who played Lego as a kid? Yes. And you, not everybody. But I suspect that a lot of people played Lego as a kid. I played Lego as a kid, and I play Lego as an adult also. I love that tools because perhaps one motto of Lego is easy unlimited building, giving you building blocks to build anything very smoothly and easily. And the topic of the day is, can we do the same with 3D software, 3D technology to build workflows, process, application easily and efficiently? So it's the topic of the day. So I introduce the digital backbone concept and how we can build the 3D building blocks with existing application to build a complex workflow using existing legacy application. But before starting with that, I want to present one concept that seems to me very important when someone tries to create 3D digital workflow and process. The concept, I call that projection. And projection is when you go from one universe of data and software, and you want to transfer your value, your data, your assets to another universe. In fact, this is not just an export or an import of your data. This is a projection of your data from the first universe to the final universe. And that concept is very important for me. So let's pretend that the triangle is one universe, one application, and the circle is another one. So the small black arrow is not an export. This is a projection. How I project my data from the triangle world to the circle world. And okay, we see this is not the same shape. So I'm using the analogy of shape, overlapping shapes to understand what happened. Here, we see that my asset in the initial world will be cut by the universe of the second world. So by the boundaries of the secondary world. So that's very important to understand that when you do a projection, not every time, but very often, you lose information. And another thing that seems to be very important for me is then when you make a projection like that, you have several ways to project your information from the world A to the world B. So the result may be that also. So what is the right way to project my data from left to right? Is it the first one or the second one? That's very important to understand that. Because projection introduce a bias in your data. That's the first thing I want to explain. And what we can say is that changing your asset from one world to another world tends to reduce the quality of the original data. Perhaps it will not impact the final usage of your data, but in general, you reduce the initial information. Secondly, let's pretend now that we will use that several times. I suppose that cake has been cut several times and that we lose information on that cake, obviously. So what happens if we do that? We go from word triangle to circle to rectangle. So we have two projections. And here you can see that we have an infinite possibilities as a result. So now, let's suppose that we have on the left Autodesk Alias software that exports my asset in FBX. And then we import in Blender that FBX files. What happened? We have two projections from Alias dataset to FBX that is not the same universe, and from FBX to Blender that is not the same universe once again. So here we can question what will happen to my data. the same with all combination of software. Can use that CATIA, for example, that will, for example, I can use an external tool to convert CATIA information to OpenUSD, for example, and that's not the same universe once again. So yeah, you have a projection, you have a bias, and then you go from OpenUSD and go to Unreal, for example, and use Unreal importer, and once again, you have a bias. Perhaps all will be fine for your specific application, and in that case, it's fine. But you must take care of that fact that the projection from one word to another one may reduce the quality of your information. So the idea behind that is perhaps it's a good thing to take control over projection and don't let other people, other companies do that thing for you. When you are using the exporter from CATIA to USD, that's not your code. That's not your projection. That's the projection of the software editor. When you are using the importer, the USD importer in Blender, that's some developer in the community that developed that importer with its own way to see the projection. Perhaps it will fit your needs or not, but you have to take care of that. So my motto here is don't let others define your projection strategy, because this is your data transformation and this is crucial for you. This is strategic in 3D workflows. And another consequence of that is that we have seen that if you are using an intermediate file format like FBX, for example, or USD, you add a projection step. Look, you may introduce more artifacts on your data. So you must keep that in mind, that if you choose to store all your information in OpenUSD or FBX, you have a first projection to go in that uniform world. And then perhaps you lose information, and then you go from that standard world to other specific worlds. And once again, perhaps you will lose information. So you have to be careful when you are doing projection. We have to be careful to take care of our information when we are doing that. The problem, you may say, is that, okay, but interoperability is a very complex problem, finally. It's not just, let's import my data, it's okay. No, it's more complex than that. And writing importer or exporters is not so easy. I'm sure a lot of people here have tried to write importer or exporter by themselves. We all know that if you do that, this is very difficult to implement something that is working for you. So when I'm saying, don't let other people take the control over your projection, I'm saying, okay, so develop your own projection, but you can say, but this is very difficult. So how we can deal with that? The idea, can we bring something, a platform that may help developers that are creating workflows and process to build their own projection strategy, to build complex workflows for industrial needs? So that's the main question. And here we try to answer to that question. And we introduce the digital backbone concept. The idea is to transform software, legacy software, existing software as building blocks and connect them in a common world, on a common platform in which it will be very easy to connect them and create our own projection. The idea is to avoid problem of language. Let's say, I can use that abstraction to say that each software has its own word, its own API, its own way to discuss with the developer. And the developer that needs to create projection by himself, it's very difficult for him to make the projection because he has to deal with two different kind of problems. The first one is digital infrastructure, software infrastructure, all the technical needs to drive the projection. And the other problem is the business logic of my projection, how it works, what is the strategy of projection. And what is very interesting is the strategy of projection. This is something that fit my need. This is my personality. This is the way I want to project from, let's say, alias to VRED, for example. I want to project my data from there to there this way. That is very important, and this is specific. But all the technical stuff behind that are not specific. And here, the digital backbone solve that problem and solve all the technical stuff for you and leave you the only work to write few lines of code to explain how you project your information from one software to another one, or from one software to a specific format, for example. So let's see the digital backbone as this platform, for example. Now what I can do, I can connect Blender, for example, to the digital backbone. For that purpose, we develop a bridge, a connector, that will copy the Blender data inside the digital backbone without any bias. This is a direct copy 1-for-1. There's no bias at all. And we can do the same for another software. For example, for VRED. We'll copy the VRED core data in the digital backbone without any bias also. It may be a full copy, if it's possible, or a subset of the global data set of the application. And once we have done that, what is interesting is that in the digital backbone, the Blender core data and the VRED core data are of the same type, of same class. I can manipulate with the same tools these two different kind of data. So for me, developing a projection will be far more easy than if I have to develop a specific bridge between directly the Blender application and the VRED application. So here is the projection. It's simply a Python script, for example, maybe something else, but here we can use Python script. And that script will rely on the platform to solve all technical problems. So in Python, with few lines of script, I can project my Blender asset in VRED assets. And I have a demonstration of that just after. For your information, the connectors are written in Python also. And the number of lines of code in Python for the connectors are about 1,000 or 2,000 lines of code. And once it's done, these connectors are forever. You do that only one time and it's solved. After, you have to focus only on projection code. And here the projection code is only 300 lines of code. A beginner in Python can write this line of code. That's very interesting. So here, for example, we have a direct connection from Blender to VRED without using an intermediate file format. So what it gives, I have a video. So short video, you have on the left, you have Blender, on the right, you have VRED. And we have the small connector in each software as a plugin. And so if I run the video, you have the toy truck, a very simple model, just for the demonstration. But here in Blender, we connect to the digital backbone and we say, okay, I want to save that project in the digital backbone. And okay, then here, by clicking that button, we say we want to project the Blender dataset to a VRED dataset. And now on the right, we connect to the VRED to the digital backbone and we say, okay, can you load the project toy truck? And here in the digital backbone, since we have made the projection from Blender to VRED, the VRED dataset already exists now. And VRED just has to load native asset, VRED assets, and to synchronize with it, and to load that in the application to reveal it. So now you see, you have a projection from left to right. We convert basic material at that stage, but you have the projection is made. And we use no intermediate file formats. We convert native Blender data to native VRED data directly. So now, if I do that, I have a workflow now. I can create data on the left in Blender. Let's say that I create the model in Blender and I push information in VRED. For what? For visualization, for example. I can prepare my scene and put lighting, environment, and prepare the final rendering in VRED. But what happens if I change my initial model in Blender? So if you write exporter or importer, you may have face the difficulty to synchronize the work, because if someone changes the Blender model, what happens to the VRED model? And updating the VRED model is a very difficult task for the CG artist. So here, what happened with the digital backbone? So same situation, but now the Blender operator will change something. Remove one part of the toy truck, and we'll save that to the digital backbone. And on the right, another operator, the VRED operator, let's say, for example, that it changed some materials. So let's turn the blue to the color of Laval Virtual. Okay. And now it will save the asset of VRED in the digital backbone. So now we have two different copies of this project. But what happened here is that by pushing the projection button, we will have the ability to merge the modification of Blender and VRED now. And we will get the modification of the dataset in Blender that are projected in VRED without losing the work that has been made in VRED. So that feature is an automatic benefit of the digital backbone. The guy that worked the projection from Blender to VRED has made nothing for that. It inherits from that feature from the digital backbone that take care of all that problematics. So that's very important to understand that we simplify at the maximum level the work of the guy that created the projection. It simply say, okay, here is my Blender dataset. Here is how I want to project my dataset in VRED using native dataset from Blender and VRED. And by describing that, creating projection algorithm, strategy, and giving that to the digital backbone, all other aspects is taken by the control by the digital backbone. Let's continue on my presentation. So take back digital backbone with the connection of Blender and VRED. Now, what happened in this situation if I'm doing that? I'm connecting two instances of Blender to the same dataset in the digital backbone. What it gives? It gives Blender collaboration. And I have a video of that. So here you have two instances of Blender. And we connect the two Blender to the same project in the digital backbone. And yet there is no projection at all. This is the same dataset. So now in the Blender on the right, we say, okay, please load the dataset from the digital backbone. So since this is native file format, native, not file format, but dataset, there is no extra work to do. So, okay, we have the same project now. And you have two users that are working on the same project. Now, what happened if the guys on the left, once again, change the position of one part on the toy truck, and on the right, the guy is changing, I suppose this is a color, like we made in VRED, but this time this is in Blender. If here the two users push their data changes in the digital backbone on the same project, there is a divergence in terms of data modification that are taken into account in the digital backbone. And the digital backbone will do an automatic merge of the modification. So what happened? You have two different users that are interacting in real time, not in real time intensively, but it may be real time, in Blender on the same project. And you can have as many users as you want. That's a direct benefit of the digital backbone. If you want to have 10 users playing in the same project using Blender, it works. You can also do that offline because you can synchronize with a local database, or you can have a server and synchronize the server and have a local copy of, automatically the digital backbone can make a local copy of the data. You go home, you disconnect from the server, you continue to play and synchronize. And when you come back, you can have an automatic synchronization of the data. All that feature are made by the digital backbone once again. Of course, we have made that for Blender, but we also have exactly the same benefit for any application connected to Digital Backbone, because here VRED, I don't put the video here, but you can come on the booth and we have a demonstration, a live demonstration of the booth. VRED become also collaborative software, the same way as Blender become a collaborative software. So now that's a direct benefit of the Digital Backbone. And what happens if we put back a projection? Then here you have a workflow. And on the model, initial model, in your workflow, you have several people that are collaborating to create the geometry of the model. Then you push the resulting model to the VRED world. And here you have a collaborative session with several VRED that are playing with that user that are working on the final version of that projection to finalize the model. But if one of these users is modifying the geometry, even collaboratively, once again, you push the content, the modification, and every user on the right in VRED will be updated with the geometry modification. So here you start to see, say, an advanced workflow. But we can imagine far more complex workflows than that using the Digital Backbone. For example, here is the idea that we can create custom application in the Digital Backbone, because if we can connect legacy application like Blender or VRED, you can develop your own application also and specify what is your data set, your specific data set. And this is very easy in the Digital Backbone, and create your custom application, let's say using, for example, Python and PySide 6, for example, for the user interface. And the Digital Backbone will take care of your data. And what is very interesting is that the Digital Backbone will produce for you all the software infrastructure that is needed to very easily build your custom application. Another benefit is that, for example, we have Blender on the left, we have VRED dataset on the right, is that all data that is stored in the Digital Backbone are of the same class, of same type. So I can reference from my dataset natively Blender dataset or subclass of Blender dataset, and the same for VRED. And here is what I call a meta structure, because here I have my project that reference external structure from external software, but in the Digital Backbone, all is uniform. So I have an appropriation of all this data set and structure and create my own complex data structure built over external data structure. So that's very powerful, because now I can create a more complex application where my custom application will do the orchestration, will organize the work of my team using Blender and VRED, and will structure the work by saying, okay, for example, my orchestration application is maybe very simple, and just say, okay, I will create my notion of project management, and my concept of project will reference one Blender project for the geometry and one VRED project for the final rendering. That's my choice. Of course, you can put Katia on the left, you can put what you want. And then I will structure the work of my team by saying, okay, now for that project, hey guy, you are the Blender operator. You have to connect to the Digital Backbone and open my project and attach your Blender data in my project. And it will be done automatically. So the Blender operator will feed the project with the Blender data. And in the orchestration, we can say, okay, now we have a Blender data of that version. We can push the data to the VRED project and attach the VRED resulting from the projection to my structure, my project structure. And I can say now to the VRED team, hey guys, now work on that project in the Digital Backbone and reach it to finalize the rendering. And here I can manage all the versioning during that. I can create versioning on my project, say, okay, this is version 1, version 2, version 3. I can choose when I switch from version 1 to version 2. So I can create a complex industrial project and create what I call the meta application. And doing that, I'm using external software like Blender, VRED, Katia, or USD framework to create complex meta application that will fulfill my needs. And as I control my data, as I control my projection algorithms and strategies, as I control all my structure and my process, I gain sovereignty on my process because I can decide what I do with my data. I can decide how I store my data and what I do with my data. So I think this is a very interesting way to organize and structure workflows and industrial application. Just here, an example of that very small application that is written in Python. This is just for the demonstration. We have created a very small application with a notion of project, and we describe the data structure of that application. You see, this is a description. We have developed a description language of the schema of the information. And you describe here my project with a name and description. And then you say, we have an attachment. We attach to that project the VREDs and graph. And we attach also Blender data. Blender data is the core data of Blender. And we attach that to my project. And doing that, I created my custom application. So this is very easy. Describing my schema and developing few lines of code in Python, I can create that simple orchestration application. So to resume, what are the benefits of the digital backbone? This is a way to easily create very powerful workflows and industrial applications. It gives me a way to take back the control over my workflows and establish as much as possible sovereignty over my workflows and my data. We have a community edition that is really available. We are putting it on the website. This is just now, La Value 12 is the official launch of the digital backbone. And we want to put all these connectors and projection example in Python. We want to put that in open source. So you can use it freely and develop your own projection just by copying the existing projection algorithm and strategy and modifying this strategy for your own usage. So if you're interested by that, just come to visit us on our booth, booth A107, and we can show you a live demonstration if you want and explain you how it works. And once again, I said that this is very easy and accessible to any Python developer. We don't limit the digital backbone to Python. You can develop your application using C++ and any other language. So at this stage, we support Python and C++, but we'll open that to far more language in the near future. So if you are interested by that, don't hesitate to come and on our booth or to visit our website. The URL is lumiscaphe.com/digital-backbone. Very soon, you will have access to the free download and access to the open source code to play with it, at least for Blender and VRED. We plan to put also direct connectors for USD, for example, maybe very useful just to play with USD, but also for Katia. Alias Studio probably will test it also, and we will continue to develop some bridges. But if you want, you can also by yourself create your own bridge and own connectors and own projection strategy. This is very easy to develop. So here is the story. So do you have any question?
So now you have experience with VRED. Just for example, you're talking about VRED with Blender together. But do you have a plan to next step to import some of the file from the Katia or Unreal Engine or Unity or something? Do you have any your roadmap to produce?
Yes, of course. This is not limited to to VRED and Blender. Of course, this is just the first connectors that we developed, and we plan now, in fact, to develop connectors, bridge, and connect Katia to digital backbone, but connect also Unreal, USD, all. We have no limits. In fact, we have no limits, just human time limits. But as I said, it took between, let's say, 2 weeks for an advanced engineer to develop a connector from a new software to the digital backbone. Of course, the software must be open. We must have a SDK, an API or something to connect the core data of that legacy application to the digital backbone. But if it exists, then this is 2 weeks, perhaps 3 weeks maximum of work. And when this is done, when you have done the connector, it's forever. Perhaps if you have a new version of the application, of the legacy application, you have to upgrade your bridge, but this is very small modification. So this is that's what is very interesting, is that we plan to put the maximum number of connector and bridge accessible in the community. So you have to just download the bridge and just concentrate your work on the projection and workflow. That is far more easy than creating the bridge. So anybody can create a bridge, but it's far more difficult than creating projection now. So, but it's not so difficult. It's possible because Digital Backbone simplifies the work in any case. So next one will be perhaps, we have to decide, but perhaps USD connector or Unreal Engine connector, why not? Or perhaps Katia connector, we'll see. For example, for Katia connector, probably it will not be free because we have to pay for SDK, maybe a license to pay to deliver that. So it depends. Sometimes it will be not free because there is something to pay. But the idea is to open the digital backbone, the 3D digital backbone, to as many people as possible, and to create a community around that, to share what you have done. If you create a projection algorithm or a connector, you're welcome to put it on the website and to share that with other people.
Hi. The other question is, I see your backbone is just either standalone platform or just it's an idea only. It's a real software platform or just is your vision.
You need the digital backbone?
Backbone is a software platform, just either Lumiscaphe, Petrol 3D platform, or just it's a connection.
The digital backbone is like a framework, an SDK, in fact, that make it easy for developers to integrate these development tools and develop their connector over that. For example, if you are in Blender, you have an add-on in Blender that creates a bridge with the digital backbone. And if you want to create the projection in Python, for example, you have to import a module in Python. And once you have done the import, Python is augmented with all the features needed to work with a Blender dataset and with a VRED dataset. So you have a very simple API to develop the projection algorithm. And that module, Python module, is available for free to download. So, okay. So you have just to say for a Python developer, you have to just do pip install DS Viper. This is the name of the...
So Lumiscaphe is just development, this a Python library.
Yes, this is like a Python library. There's other tools, but mainly you have a Python library to import to Python just to start to work with the digital backbone. It's very simple.
Okay.
And we'll put some tutorials on the website so you can follow the tutorials to develop your own projection or your own connector.
Thank you. Thank you, Jim.
Another question? That's okay. Time to lunch. Thank you very much for your attention. Don't hesitate to come and visit us to our booth. Thank you very much for your attention.